Okay, so this is the period just before, like, so the button is started, but we won't go live. So I think actually I'll just start to warm up now, get everyone ready and all this, because we never matched it perfectly. So that people sort of see me start to get the talk. Just 1 second. I made a mess of that. I apologize. So I'll start off again. And my name is Kevin O'Brien, and I'm in the west of Ireland. And I'm joined here. I'm delighted to introduce Joseph O'Brien. Apologize for that. The Zoom setups are very complicated. And so Joseph O'Brien is going to be presenting data analysis and fantasy football. I'll let him introduce himself properly shortly. So just before we begin, I'd like to say hello to everyone who's joining us on the webinar today. And something that we always like to do is actually sort of see where our viewers are from. So if you can just say hi from Ireland, hi from Sweden, hi from Poland, and so on, because it really gets a real sense of how big our community is, and we really enjoy that. Secondly, actually, we'd like to thank our sponsors, Jumping Rivers, who is sort of providing ongoing sponsorship for the YR webinars, and plenty of our user groups around the world as well. So they're great supporters, and we'd like to thank them. And so without further ado, Joseph, I'll let you hand over there. So this is Joseph O'Brien. He's from a PhD student in the Maxey Centre in the University of Limerick in Ireland, which is very close to me. And his presentation is about essentially R and fantasy football. Joseph, I'll let you take it away.
Perfect. Thank you, Kevin. First of all, I'd like to thank the organizers here. I think this is a great group. I've seen a few of these talks over the past year or so, and some of them have been really good. They give you a real good insight as to how R is used in different disciplines and some of the cutting edge techniques that are currently going on in R. So they are highly enjoyable. So if you're just here for this one, please do maybe think about watching a few more. Today, I'm going to talk about fantasy football. So it's an online game. If you've played it, you know all about it. If you haven't, you don't. And I will give a bit of a detailed description as to how it works later in the talk. But it's really a vehicle. I mainly want to talk about web scraping and how we can do that in R. Okay. And that's going to be the majority of the talk. More than a half, I think, is going to be going through some of the techniques you can use to web scrape. And then towards the end, I'll zone in on a specific project we've completed that actually used a lot of web scraping, and I'll show you some of the results from that. First of all, maybe a bit about me. As Kevin said, I'm a PhD student in Maxey, which is an applied mathematics group at the University of Limerick. I'm a nearly finished PhD student, and I say that because I'm currently thinking about what to do next. So if anyone has any real interesting opportunities, I'd love to hear more about it. My interests generally kind of lie at the intersection of mathematical modeling and data science. So the research we do generally looks at very big systems. That could be how things spread on Twitter, how some threads on Reddit and things like that get popular, successful fantasy football managers. And the idea is that we try to understand these big systems by looking at them from a kind of different perspective, using mathematical modeling and justifying our results using data science. Okay? They're generally underlying large scale data sets that we try to look at as well. From a programming perspective, I'm a pretty big R user, but my initial language was probably MATLAB. That's where I started. And in the past 2 or 3 years, I've changed and geared very much towards R. Mostly because I think it's a one size fits all application. It's fantastic for data analysis, data visualization, hosting websites, preparing slides. It's really fantastic in a whole lot of ways. But depending on the problem and the collaborators, I do use other languages. Python for some things. Python because it's very popular. A lot of people I work with use it, so it's good to have an idea as to how that works. And more recently, the Julia language, which I tend to use for heavy computing. It's so fast. That's the best way to describe it. If you haven't tried to play with it, you really should. If you're doing anything that's taking hours on your PC, it's a game changer in my opinion. There was actually a fantastic YR talk before Christmas about a framework with both R and Julia. It was a brilliant talk and really enlightening. So if you are trying to learn a bit about Julia, do check that out. I thought it was great. A few different ways to get in touch with me. There's my website there, joeobrien.ie. That's coded in R, which is why I said websites. You can get me on Twitter pretty quickly. If you have any follow-up questions or anything, that's probably the best place to get me. And you can get my GitHub there as well. And we're going to use that in a while. So some of the code that I'm going to show you is hosted there already, and you can check that out. Okay, so plan of attack for today. I really want to introduce what is web scraping, because I'm imagining some people maybe haven't heard of it before, and I want to give you an idea as to why we should actually learn how to do it. And if you do want to do it and you want to do it in R, I'm going to talk about some of the key packages that we can use to do that. There's a few good ones, and I'll show you them in practice as well. And I'll do that in the demo. Okay, so there's a few different examples I'll show you, which will take up the majority of the talk. And I hope you can pick up some nice techniques and tools from it, which might prove useful to you down the line. And after that, I'll talk about a project we conducted on Fantasy Premier League that used an awful lot of web scraping. I'll talk about that in a bit more detail in a while. Okay, so first of all, really, what is web scraping? The important thing about the web is that it looks very pretty and all the sites are nice, but in reality, it's just somewhere that data is hosted, right? So all the content that you see on a website is hosted somewhere, and it's not hosted in the pretty form that you see it. So to get it in that nice form, you need developers to code, right? So most websites have a certain language. Generally, HTML or JavaScript would probably be the two main ones, but there are others. So here's an example homepage of the Fantasy Premier League website. It looks very nice, very pretty. But if you dig into the code that actually made that website, it looks something like this. Okay, not so pretty, but the idea is that it's coded in a language. And like most programming languages, once you get an idea of the syntax, you can do an awful lot. So the challenge is really to become comfortable with that syntax, and then once you do that, it's pretty easy to obtain information from the websites. Okay, and I'm going to show you a number of different examples as to why that's the case. Next thing is sort of, well, great, that's what web scraping is, but why should we do it? Is another good question. There's a few different reasons. So I tend to think of this from an academic perspective, but this is really applicable to an industry problem as well. There's been a lot of really good research and fantastic publications that use different data sets to look at previously unconsidered things. The classic examples, I think, are kind of Stanley Milgram's research into the 6-degree separation. So this idea was that he got this data set by sending letters around the United States and seeing how long they took to get from one place to another. And they showed that on average, people can be connected through 6 links. So that was really groundbreaking research, and again, based on the idea of using a different kind of data set long before web scraping, but it was a very, very novel data set. Web scraping has become more popular in some studies, such as those that look into citation dynamics. Okay, so how do scientists reference one another? There's a lot of data there. The data's been there the whole time, but it's only in the past maybe 20 years that people have actually started digging into it to try and understand the dynamics. And it's a really active area of research right now. And again, it's really based on this idea that novel data sets are good. Another reason, and I come from most of my research being in the field of network science. And I say that some fields suffer from what I've coined the Zachary Karate Club syndrome. And if you don't really know network science, you've no idea what this is, but no doubt there is an equivalent in your own field of interest. And the idea is that an awful lot of publications and research use the exact same data set all the time. If you remember from a few years ago when R and the Tidyverse were getting big, the IRIS data set was always used as the example. Well, imagine that, but in academic research, right? So much so that there's actually a Zachary Karate Club, which is it's a group in network science whereby the first person to present at the conference using that data set get an award. So that's how common it is in the field. People think that's a good thing. I don't know if it is. I think it's more exciting to look at different kind of data sets. And finally, and this is probably where it's most relevant to industry as well, is that it's a chance to research something that you actually really care about. Maybe it's something that is a specific area of interest to you, and that data set isn't currently available, so you might have to collect it yourself. Okay. So how do we actually web scrape? Given that it's an R venue, I'm going to zone in on the R part. There's two main packages, XML2 and RVest. RVest is a Hadley Wickham package, so it links very well with the Tidyverse. It's RVest, so I think that's a pun on harvest. So we're harvesting data, which is what you can kind of get from the image there as well. You see a scythe in action. So we're trying to parse this data or harvest this data from a website into the Tidyverse is the idea. RVest is pretty heavily based on Beautiful Soup 4, which is a Python module, and it's a great one. So when I started web scraping, I actually used that before converting to R in more recent times. But if you do use Python, check Beautiful Soup out. It's fantastic as well. Okay, that's kind of just a brief overview of what web scraping is, why we'd want to do it, and how we do it. What I'd really want to do now is give you some examples. So I'd like to walk through maybe 2 or 3 different cases where you can scrape data and how we'd actually go about doing it, just to give you an idea as to how this works. Okay, so I'm going to stop sharing because I want to share my R console. If I could just share my screen, I think is probably the best option. So the first thing is that on this website, so my website here, you can get, I don't know if you can see yourself in this. You can get the slides and code that I'm going to use here. So down here, talks, there's the slides that I've been using and will continue to use, and also the code, which is available on the GitHub here. Okay, so it's in this GitHub in the YR scraping. So there's 3 different R scripts here that I'm going to use. I have. Okay, yeah, that's okay. Okay, so the first one I want to talk about is Reddit. Okay. So I'm going to have this console. This is my R window, and the first thing I'm going to do is load in the packages that I'm going to use throughout this this talk. Some are more important than the others. Some are pretty aesthetic, like GGSci and scales here, so you don't need to worry too much about those. But the rest of them are pretty important for what I want to do. Okay. So I think most people know what Reddit is. It's an opinion board kind of where you can comment on different threads, and there's so many of them. You can really, anything you're interested in is on Reddit. So this is in the Irish subreddit, and I seen this post today. I thought it was kind of funny. It was someone asking the question, is anyone else stuck with a conspiracy theorist? So this poor person's mother has slowly become a conspiracy theorist over the past year. And I think a lot of people are in the same boat. That's why I thought it was funny. It's funny until you think about it, I think. So let's see. So the idea is that I want to look at this post. Okay. So the idea with Reddit is that you make posts and people can comment on it. Okay. So down here, there's plenty of different comments. Okay. And just like I said before, this all looks very nice, but if you look behind the scenes, so the way you do that is, I'm using Chrome here, but I'm sure most of them are the same, is that if you right click and view page source, I already have it clicked here, so I won't do it. You get a window that looks like this, okay? Which is actually the code behind the web page, okay? And that it's kind of hard to parse and kind of hard to understand, but let me just show you. So if I take this, anyone else stuck with a conspiracy theorist, if I search for that using a Control F, that should work. Maybe I'll view source again. View page source. Okay, this will load, and if I do that, I can find that bit of text. Okay, so that bit of text is there, and it's in the mix of all this stuff, but it is there. It's just a matter of how can we parse it. Okay. So let me show you a bit how it actually works in R. So this is just the URL, right? So I'm storing the URL here, which is just the one that's on the web page. And I want to interact with that web page. Okay, so the idea of doing that in R is that you use the XML2 package and you use this function read HTML and you pass it the URL you've just used. Okay, so let me just load all these packages in and store this URL. And then this is just extracting the information from that page, okay, the one that I just showed you. And now that's done, we can look at it, right? So I've stored it in this thing. You see that it's got two things, right? It's got a head and a body. So the head's kind of the setup for the page, while the body is actually the content. And let me just talk a bit more about how this language actually works, just to give you an idea. The key thing in this this HTML stuff is that there's tags. Okay, so for example, the title of the page is in the title tag, and the title opens with these angled brackets with title inside, and it concludes with the angled brackets but with the slash. Okay, so the thing that's between those two things is the title. And then there's other information there, such as the link, which is the URL associated with it, and a number of different things as well. Okay, but let's just start with this for a moment. Okay, so I can interact with that by saying, well, take that Reddit web page that I just parsed from the URL. Okay, and then using rvest, I'm going to interact with the tag title. Okay, so that's done by using this function HTML node. Okay, so if I just run that part, okay, so I take the text and look for the title. That tells me that it's there. Okay, but it's more of a pointer than anything else. So to actually get the text, I have to pass that to rvest again and get the HTML text function applied to it. Okay, but once I do that, I get pretty much what I was looking for. Okay, so I get anyone else stuck with a conspiracy theorist in the just as I hoped. Okay, so that says interact with the tag title and get the text. That's all it's doing. Okay, very good. So what else can I do? For example, this is a funny comment. I'm very thankful my mother has next to no computer literacy. Right? This is someone trying to ease their worries. But what if I wanted to get that text into my R console? Right. So I'm just going to search for it again. And that should be here somewhere. I'll just load this again. So, yeah, I might have to reload this page, see what's on top. I'm very thankful. Yeah, that should work. So I'm very thankful. Well, that's not in the document just yet. Sorry, this should be okay. Here's some ideas. Well, here's another comment, right? One of my mates believes COVID is a hoax, right? I just found that by chance. So that's a comment, and if I try to figure out what that's in, I see that it's got a tag here, P. Okay, so P stands for paragraph in the HTML literature, but it tells me that that's in P, and it has this class. Okay, so just like the title, it has a tag P, and it's a text inside that P. But it also gives us this information that it's got a certain class. So the idea of that is that any bit of text is going to be in a P tag, but to get specifically the ones that are comments, you need to include the class as well. Okay, so if you just search for P, they'll give you every bit of text, but we want a specific type of text. So in the R function, the way you do that is you say, well, I want P, right? That's a paragraph. And then I do this full stop underscore and tell it the exact class that I'm looking for as well. Okay, so if I do that, so run this, what that run really does is extracts all the comments that are on that Reddit page. Okay, so I've looked for the P tag and told it the class as well, and that got me everything I was looking for in terms of comments. Okay, more, right? So this is the Reddit Ireland homepage. It looks like this, and suppose, right, that the example I just showed you might seem a bit convoluted because you could just go on that post and get all the comments yourself. Why is it helpful? Let me give you an idea, right? So first of all, Reddit order things by using a certain algorithm. So this hot thing, I'm going to order them chronologically. Okay, so make them new and look at the most recent posts. Okay, and I see that there's actually been none in the last hour. That mightn't work in the example I'm going to give you. There's 1 to 4 minutes. Okay, So what I'm going to do is I'm going to take that URL of Reddit, right? So this URL I just had up there in the original subreddit, and I'm going to read that, okay? So that's all that function does. I pass it to XML2 and requested that it would read the URL. And now let's see what I want. So suppose I want the time these things were done, okay? So I'm going to open the source just like I did before. And let me see, 5 minutes ago. If I look from minutes ago, that should give me an idea of where I'm going. Okay, so here we go. Here's 5 minutes ago. And where's that? Well, it's in, well, I can see the close. It closes in an A tag. So it must open in an A tag as well if I could just find it. So there's the equivalent opening. And we also have class just like last time. Okay, so in my R function, what I can do is say, look for the A tag with this class. Okay, and extract all the text. And when you do that, that'll give you the timestamps associated with all those Reddit posts, okay? And what else do I need? I'm gonna look for the URLs associated with each one of these things. So I see here that they're also in this A tag with the class, but they have a certain thing that's referencing them, okay? This href is actually referencing the URLs. So I want to access them. So the question is, how do I get to that point of the code? So the way we do that is we say, well, get the nodes. So HTML nodes here just looks for all the tags with this A and this class. And then I'm going to look for the attribute. So the attribute's the thing with the equals to sign with attribute href, okay, just like I've seen in the source code. So that stores all those URLs. And if I look for them, I see that they're all here now, okay? So what do I want to do? I'm going to take those URLs, and for every one of those posts, I'm going to go into it and get the comments, right? So in the first example I showed you, what I did was go into a certain thread or certain post and get all the comments. Now I'm going to say, well, go into all of these ones and get all of the comments, right? And this is where web scraping becomes useful because we can do a lot of things very quickly, okay? So what I'm going to do, I'm going to make a data frame. It's going to be a table with the URLs saved as pages and the time as times, okay? And I only want the really recent things, so the things that have occurred in the past hour. So I'm going to just do a match on that timestamp to make sure it was either in the scale of minutes or now is the most recent one. So we've seen before it said like 2 hours ago. We don't want that. We just want minutes or even more recently. So that's our recent. Okay, that's the ones that have occurred most recently. And what I'm going to do, I'm going to go into each of those, like I said. So I need somewhere to store the titles of those posts, and I need somewhere to store the comments. That's all those two things are doing. And I'm really just using the code then that I used above. Okay, so I'm reading a page. So for each URL, okay, so for each page in that set of URLs, I'm reading it, and then I'm extracting those p tags, which are comments, just like before, and pulling out the text, okay? And I'm appending them to the comments vector I've just made up there, and doing the exact same thing for titles, okay, just so I know which post it is. So if I just run that, right, and this will take a minute because it's going through all those posts, which can take a bit of time. This isn't the best way to get Reddit data, just a bit of a disclaimer, but it's a good example of how these things work. So that's it, Ren. Okay, that worked pretty quickly. So I'm gonna now take those titles and those comments and make them into a table, just like before. And let me see what it looks like. It's pretty much what I want, okay? It's got all the comments of all the recent posts, and now they're in the table. So once you've done that, right, I'm not gonna go into much more detail on this. The worm's really your oyster, okay? So you've got all these posts and all these comments. You can very quickly do a lot of interesting things, right? One thing that springs to mind pretty quickly is some sentiment analysis. That would be a nice way. What's the sentiment of Ireland in the past hour? And how does that change throughout the day? You could check things like that. Or any other NLP problem you're interested in, or even if it's just collecting information, right? So how these threads are changing over time and the size of them, okay? Multiple different questions like that. But that's that's just an open example to give you an idea as to how web scraping works. Okay. I don't know if there's been any small questions or big questions. This could be a nice place to take them if so. No?
Not yet. No, keep going there. Yep.
Good stuff. Okay, so that's one collection of data, an idea of how you'd scrape Reddit and things like that. So if you want text from a website, that's a good way of approaching the problem. Okay. Now, sometimes, right, we tend to think in terms of columnar data. That's what we want. That's the tidyverse. That's the way we structure our data in terms of tables. And a lot of the time, those tables are actually on websites, and people copy and paste from them and store them by themselves manually, just from an online table. And that's okay if there's a few rows, but if there's hundreds or thousands of rows, it's a bit difficult. So I was thinking about this example this morning. I'm a relatively big Bruce Springsteen fan. Okay. I hope everybody here knows who Bruce Springsteen is. If you don't, YouTube him. It'll change your life, I promise. But one thing Bruce Springsteen started doing a few years ago was releasing old concerts. Okay, so there was always this kind of bootleg kind of stuff where people recorded concerts in the audience and then shared them online and with their friends. And I think they realized that, well, that's okay, but maybe the quality is not great and the sound's not great. So what they started actually doing was making official releases of past concerts. And I've been collecting these for a while as they've been officially released. And there's been, I don't know how many of them now, there's been, what's the end of this table? There's been over 60 at the moment. They happen once a month usually. So what I was doing for a long time was checking my collection against this table. So checking which one I had, comparing it with this table. And at some point it just turned into a bit of a headache. And I thought, if I just had this table in a spreadsheet or something, it would be much easier. I could just keep a record of what I have, what I don't have. So got me thinking, right, I can get this table. And right, what some people would think about doing is just copying and pasting each entry and storing it in an Excel sheet. But if you can web scrape, you can actually do this in a more efficient manner. Okay. So I showed you how to view page source before. Let me show you a different way you can actually find out what's going on a web page. So if I right click this and what do I want to do? Inspect. Okay. This opens this this window. Okay, just at the side of my Chrome here. And what I can kind of do actually is tell you specific parts. So instead of me control Fing and searching for certain things to find out what the tags are, this is kind of an interactive way of doing it. Okay, so if I go through this list, it tells me, so it highlights the boxes as to what I'm pointing to. Okay, so if I do this, so if I click on that table there, I can see that that's actually the table that I'm interested in. Okay, right, and that's okay. So I could tell R now to look for that table with that class and extract it. But sometimes there's multiple tables and they have the same class, so you want to point it to a specific thing. And the best way to do that actually is to, well, hover over the part that it's found, right click it, and copy the full XPath. Okay, so the XPath is literally a direct point into the table that you're interested in, right? So if you found the thing you wanted using this inspector, you can find the exact reference to what it was. Okay, so back to my R window, so this is the second bit of code. If I read that URL, okay, so just like before, if I read this thing, it's going to have two components, a head and a body, and I want to interact with the content. This thing here is the XPath that I've just got from the inspector. And what I want to do is tell RVest to use that HTML nodes, okay? And before, what I did was say, well, go for an A tag with a certain class. Instead, I can just say, well, the XPath is this, okay? So I've searched for the XPath, and that is what it's told me, okay? And now it points towards the table, which is what I wanted. But again, it's just a pointer. So now I actually want to get the table. And of course, in this wonderful package, there's actually a direct, or this wonderful library, there's actually a direct way of doing that. There's a function called HTML table, okay? And it even handles things like missing values, so you can tell it to fill with NAs if you want. It's not the case here, but you can. So I get this pointer towards the table, and I tell RVS to make a table out of it, right? And if I run that bit of code, you see that the table is now there. That was everything that I was looking for. And if you look, it's actually stored in a list. Okay, so it's the first entry in a list. So I can pluck that using the per package, and then save it as a tibble, right? So I can just use as tibble to convert this data frame into a nice, tidy data frame in R. Okay, so you can see that's everything I wanted. It's got the number, the venue, the city, concert date, release date, and notes, which is exactly the table that was on the Wikipedia page. Okay. So I'm going to clean it up a bit. I'm going to get rid of this thing. I can't remember what it's called, a hash, I guess, and also remove those spaces just to get it in a tidier format. And then I'm also going to set these dates, right? They're just strings at the moment because of the way it reads the table, but I'm going to convert them to an actual date, right? A date class. So that's everything I want to do. So I can run this entire code. And once I do that, I stored it in this df. I get everything, including a nice date and all the information from that Wikipedia page that I was looking for. Okay, so that's great, right? If there's a table online you want, that's a really good approach as to how you can actually get it into a very usable format in R. So then you can pretty quickly do some analysis. I've done probably the most basic of basic here. So all I've done is figure out what tour the concert was from. So they're released sporadically across different times. So if you just see the Wikipedia page, the first one here was from 2012, the next one's from 78, then 75, then the 80s. So what I'm going to do is tell it what tour that was. So this was kind of lazy. I just specifically told it using the case when. Ideally, you'd actually get that information from another table and then do some kind of join, but I just did this morning in the kind of the quickest possible way I could. So I'm going to do that. I'm going to create a variable tour that tells what tour they're on. I'm going to extract the year from the concert date. Okay, so that's all this is doing. And then I'm going to count how many happened in each year. Okay, so of the officially released concerts, how many have occurred in each year? That's all that's doing. And then I'm also going to know what tour it is. And then I'm going to plot it, okay? This is a pretty basic bit of analysis, but you can see immediately that from a rather rudimentary idea, you can get some really nice visualizations and information, right? So whatever you're interested in, there's a pretty good way that you can extract information about it using these kind of functions, okay? So this is the a bar chart counting the number of times that a given year has been officially released. Okay, so you can see there that the top one was 8 releases. That was 1978, which is a big tour for him. And it's happened continuously through time. And you can see that he does have a pretty good spread. So using that data, you could kind of do something maybe like predict what's next or something like that. I don't know. But it's a good idea as to how these things actually work. Okay. That's that example. Any questions on any of that?
No, not yet. No, that's
Nope.
very clear. I'll let you keep going there.
Good stuff. Okay. Right. Lastly, Fantasy Premier League. I guess some people are here not for the web scraping, but for the Fantasy Premier League part. And if that's the case, let me give you an example of how you can scrape information from that game. So this is the Fantasy Premier League. Now, if you don't play it, I don't know if this code will work. You might need to have some kind of account, but maybe someone can check. But this is what the game looks like. And what I'm going to do, first of all, is maybe give you a brief rundown as to what Fantasy Premier League actually is. So it's an online game based on the real life Premier League, so the top division of English football. And the idea is that you're given a virtual budget, okay? And from that budget, you want to assemble a squad of 15 players, okay? And then each week you choose 11 of them to start. Okay, just like a real life football team, you have a squad, but you only choose 11 to start. And then based on that 11, you receive points based on how they do statistically in the actual game. Okay, so that's really all the game's about. So you drop 4 players to the bench, and based on that 11 players, you get a certain number of points. And the thing you want to do is maximize those points. So the person with the most points at the end of the year wins. Okay. You also choose one player who's a captain. They receive double whatever they would have received. And in its simplest form, what you really want to do is figure out the optimum way of spending that budget to maximize your points. Okay, that's just a brief overview of what Fantasy Premier League is. And I will talk more about it in a few moments, but I want to get back to the scraping. This is the last real example I want to talk about for now. So the page kind of looks like this. You have a page, you're in a number of leagues, so this is where you compete with people. So for example, here's the Maxi Classic. This is my work league. And what you have is a group of people who are competing. You have their scores, that's the total number of points they've got in the season to date. And you have this game week, which is their points so far this week. Okay, so let me think. That's nice. It tells me the current state of affairs and how I'm doing at the present point in time, but it doesn't tell me how the entire season has went for me. Now, Fantasy Premier League's one of the nice websites, and there are plenty of these. Reddit's one of them, so this is the better way to scrape Reddit that I suggested. And they're better in the sense that they have an API. Okay. Now, things with APIs are generally easy ways to access data. So if you Google the site you're interested in, and if they have an API, they'll have pretty good documentation, and they'll tell you how to get information from that API. And fantasy football is no different. So the idea is that each league has an associated number. So if you know the database language, this would be the primary key, I guess, or the way of identifying a given league. So this number of our league is 788535. And if I look up the API documentation, it tells me how to interact with that. Okay, so the present web page, while it does have a HTML background, it's much easier to interact with it in the using the API. Okay, so all I've done there is really change the URL to API, and everything else just works. Okay, so now that previous information on that web page is now available in this. It's a JSON format, right? So it's a language that interacts with JavaScript. It's probably a good thing to figure out if you want to do some web scraping, because a lot of them use this data format to provide information. So I can think of Twitter as one example. Reddit also offers data through a JSON format, so it does consistently appear. But it doesn't really tell me that much, right? So what does this thing tell me? It tells me the player's rank, right? It tells me their name, it tells me their points, their entry ID. Okay, so this would be like a foreign key, right? So that key tells me who a player is. It tells me the name of their team, and it tells me how much points they've gotten this week. Okay, that's kind of everything you need to know in there. But what if I wanted to do something different? Okay, so let me go back to the console for a moment and show you a few things. Okay, so that's just the URL that I had. Okay, and the way I can parse that URL is using this JSON Lite library. Okay, and they have a function in that library called from JSON. So that loads that URL JSON directly into R. So if I do that, what do we see? I get the information. I get a lot of lists, right? So, but it's everything I needed. Okay. So R has this JSON Lite library package that that converts the JSON itself into a list. When I originally did this stuff, I used Python. So they have equivalent functions that convert it to a dictionary. Okay, so whichever you prefer, they both work. But the main thing is that I can see that the table that I was interested in is actually there. Okay, so I'm going to extract those informations from the list using per. Okay, so you can do that by hand, figure out which one you have to extract. And when I do that, I just get the the data frame that I was interested in. Okay, so that's the exact thing that's on the website, but now in my R console. Okay, and if that's all you wanted to do, that's fine. You might want to do more though. So for example, what if I wanted to figure out how people have done over the entire season? Okay, so what do I need to do that? I need the points they've scored each week. Okay, and so I have to figure out a way of actually obtaining that data. So let me show you. Again, there's API documentation, so they're actually pretty good at telling you how to do that. So it's another API access, and now I'm looking for this database, so the entries for players, and now this is the primary key of that database. This is my user ID, which was in the other database as well, but it was a foreign key there, right? So there's the 11642, which was my name. So using that key, I can access the API from another direction, and all this is in the documentation, so it's no problem. Okay, so now I see event. Well, that's just week, and I can see the points I've gotten each week. Okay, and that can run through time. So what do I need? I need the user ID, and once I have that, I can go through this JSON to extract the points obtained each week. Okay, so what I'm going to do, I'm going to extract the names, so the team names from the first data frame. Okay, and I'm also going to extract the user IDs because that's what I need. Okay, and then I'm going to try and make a table where I take the user points each week, the team name, and the week we're looking at. Okay, so that's just making an empty table for now, which I'm going to fill in a moment. And the idea is I'm going to go through that user ID vector, which I just made. So 4i in that length, however many people are in the league. I'm going to find out who the user is, what their team is. And then I'm going to extract that JSON file from the URL I just showed you, but I'm going to paste in the whoever the user is at each point. Okay, so that's just be a paste. And when I do that, I'm going to get a list, just like the first time, but I'm going to pluck from it. I'm going to get the points, which is what I'm interested in. Okay, so I'm skipping a few steps here to show you, but it's pretty intuitive. Once you do the pluck part, you have a data frame, and then you're just taking the thing that you're interested in. Okay, so let me do that. If I look through that, it works really quickly. And right, so what does that DF tell me? It tells me each team. It tells me how many points they've gotten each week. So this is the points each week, and this number is the associated game week or week we're talking about. So what I want to do is for each game week, so I'm going to group by the game week, I want to rank. Okay, so what position were everybody in each game week, and this is actually the cumulative number of points. Okay, so total points. So that should give me the live ranking at each point. Okay, so I'm going to do a min rank and on descending total points. Okay, so I want the highest points first. So once I do that, that's really what I was looking for, right? So now I have the total points, so how many points someone has, the name of the team, the game week, and the rank in the league. Okay, so I'm going to do a ggplot, and the code's all there to look at this. It's all pretty basic stuff, but I can get this nice visualization whereby I look at the temporal evolution of a competitor's rank within their Fantasy Premier League over time. Okay, so you can see here some really nice behaviors and things like that. And if you really wanted, right, there'd be no difficulty in making that a shiny app. Okay, like it would be very easy to do. I haven't done it myself, but you could make it a shiny app whereby the only input you'd really need would be this league ID. Okay, so if someone passes you the league ID, everything else follows from there, right? So you find out who the users are, what their teams are, and then I just extract their total points from the user ID itself. Okay, so once someone passed you the league ID, everything else works automatically. So it's a prime shiny app in that if someone told you the league ID, you could return that plot that I just showed you or a different variation of it. So it's a nice exercise of web scraping. Okay, but it's really nice the fact that all that data is there. It's just a matter of knowing how to interact with the API. Now, if a website is going to make an API, make things publicly available, they will be pretty good with documentation on how to interact with that API as well. So if you're looking for a certain site and you want to know, do they have an API? Generally, if you just Google the site and API, you should be able to figure out pretty quickly, I think. Okay, that's really what I wanted to talk about there. So that's 3 examples of web scraping, and I will go into a bit more detail on an example project that we did using some of that data. But if there are any questions, I'd be pretty happy to take them now.
Just a short one, really, is from TP Flow Specialist. Are XML2 and RVest complementary?
That's a good question. I think if you just load RVest, XML2 is a required package to use it. You probably don't have to explicitly load XML2. I just tend to do it for completeness, but you're probably right. It's within the RVest package itself as well.
Okay, just another one actually. It's just relating to sites. Now, I'm guessing that the answer to this is no, but is it possible to sort of scrape LinkedIn or something like that? Not for, let's say, personal pages, let's say company pages or event pages. Or did you ever look at an API for that?
So the general way to think about this is if a site makes money from its data, it's pretty hard to scrape. What they do is they block you if you try to ping it too much. Google is probably the worst example. I tried to scrape Google before. They just block you really quickly. They block your what's the word for it? The what's your identifier? Your online identifier.
Yeah, that's
IP address. Your IP address.
I get that. Yeah. No, I figured as much. It would be actually really cool, but yes, you're right. It's companies that make money off the data. You know, that's the last thing they want to be doing.
Sure, yeah.
Sorry, just to confirm that there is an API for Reddit. Yeah,
there is. There's a very good one actually. There's a few different ways to get Reddit data. There's PushShift, which is a website. If you just Google PushShift, you'll find it, and that is fantastic in terms of an easy access point. There's also ways to display the Reddit pages as JSON, just like the Fantasy Premier League case, and that's really easy to parse as well. But for a big collection, I've done some big collections myself. PushShift is the best option there.
Good stuff.
Now, sorry, I'm really sorry to interrupt, but I heard your question about scraping, web scraping. So apparently, you can use Scrapy, the Python library. So you can, there's like some robots that you can change the configuration that it handles all the backend for when you're like soliciting information, making too many requests at the same time, or too many requests in a very short it's a lot of time, and then like they would ask them to block you. You can use Scrapy to do that. That's how I managed to use Scrapy to scrape Amazon and a few other websites. And it's not that hard to configure. I just really don't know if I should be saying this live. Actually.
Yeah, I haven't heard of that module in Python. That's interesting. I have tried to do things like have a rotating IP address, and another thing some people do is put a random sleep time in the loop.
Yes.
They're both good approaches. How much Amazon did you pull? That's impressive.
Up to, I think it was like around 40 pages, search pages. Yeah, with the actual tag. So, but it was okay. Like, was able to just yield everything into SQL database, and was fine. So, okay. Yeah, sorry, Kevin, come back.
I think actually I'll let Joey finish up there, and we'll move on to a couple of questions there.
Yeah, I don't have much more to do, so I just want to give a brief overview of some of the stuff we've looked at with fantasy data. So this was a good work with some people from the University of Limerick, James Gleeson, who's a professor in Maxi, and David Sullivan, who's a lecturer there. So what we did was we did a big scale data scrape. Okay. So what we looked at was the top 1 million managers in Fantasy Premier League. So I looked at that table, found out who the top 1 million people were, and I extracted all the information from those people over the course of the season. Right. So this was roughly 50 million URLs that we pulled all together, and we did a lot of analysis, and I'll fly through some of the examples. So some of the things we thought about was, well, how do people, is fantasy football a random game, or is there a correlation between performances? If it was a random game, So on the plot on the left, I'm just looking at the ranks across 2 seasons and seeing how they correlate. If it was a random game, you'd expect that to be pretty noisy, but you see an actual pretty nice correlation around the diagonal there. So that's kind of, particularly in the lower left corner where the very, very best people lie, which kind of told us that there was some people that are consistently good at the game. And if I looked at across, over 10 years of data, you've seen that this correlation coefficient was pretty significant all the time. So this is using the ggcar package that I did this plot. So that was kind of what interested us to start with. And sure enough, if you look at the behavior across the season, so the plot on the left just showing the average points along with a percentiles, so a 95% percentile interval there. And what we did was we took the top 1 million managers and we split them into groups. Okay, so we looked at the people that finished in the top 1,000, top 10,000, top 100,000 positions, and looked at how they performed over the entire year. And this kind of amazed us that the better groups, it wasn't just a few minor weeks in which they outperformed the others. It pretty much happened all the time, right? So they were consistently outperforming the other groups over the course of the entire season. And you can kind of see this as well. So this is a snaky plot. So it's using G on Stratum here in ggplot. And it's showing the flows between those different ranks as the season progressed. So the plot on the left showing the top 1 million, how they moved across time. And you can see that if you were in the top 1 million, even at game week 29, there was still a good chance of ending in the top, or sorry, if you're outside the top 1 million at game week 29, so that's the yellow box, there was still a pretty good chance of finishing within the top 1 million by the end of the season. Okay. But if you zoom in closer, so if you look at just the top 10,000 people and look at how they move across time, you'll pretty quickly see that if you're not in the top 1 million by game week 20, so roughly halfway through the season, there's a very, very slim chance that you're going to finish in the top 10,000. Okay, that's what that small green block is telling us, that it's very, very hard to come from the top 1 million to the top 10,000 halfway through the season. Okay, so there's a real competitiveness there that's happening over time, and it's very, very difficult to place well if you don't start well. So some of the reasons we try to figure out why that happened, well, the first thing is that there's money involved in Fantasy Premier League, so players change price based on supply and demand. And if you look at, there's a general upward trajectory, so that's what the plot on the left showing us. It's showing us the average change in team value across time, so it goes up by on average 2 million over the course of the year. But if you look at the different managers, so the plot on the right, which is done in GG Ridges, which is a fantastic plotting tool, the distribution of team values for the better managers is vastly different from the rest. Okay, so those better managers are fantastic at building team value even early on. So even by the 3rd game week there, you can see a real shift in the distribution to the right. So that was the first real thing we noticed. And if you look at that, so here I'm showing you team value in game week 19 and looking at how it correlates with your final points total. And there's a real positive correlation here. I think we fit a linear regression through this, and we got like it's an extra million in team value halfway through the season was worth nearly 20 points. So it was a really significant effect, and we could see that straight away. Then we could think about network analysis. So, right, there's teams, so there's managers, and each manager has a group of players. So the managers on the left there, James, Joey, this actually happened, right? I finished 2nd in a work league, and that's what kind of motivated this research. I was kind of annoyed at coming 2nd. Some people have great research motivations, like curing cancer and saving the planet and stuff. I tend to base mine on personal emotion of losing. And that's really what did motivate this. So the idea is that if a player is in a manager's team, you draw an edge between them. So James has Mo Salah here, but there's another way of thinking about it. If here Raheem Sterling and Harry Kane both appear within the team, so there's really like an edge between those, right? If they both appear in team, and they also both appear in Hannah's team, so there's really a thicker edge associated with them. Okay, so if you count the number of teams that 2 players co-appear, you can kind of get rid of the managers altogether, right? They don't matter. So then you get this very, very nice network idea. And once you have that, you can look at those weights and you can identify clusters. So here we did some hierarchical clustering, and we were kind of amazed we did this. So there's roughly 600 players. If you do the clustering, what we actually find is that most managers only pick from roughly 30 players. out of the 600. And there's these real clusters of players that co-appear in teams together. So you can see the first two clusters is only about 10 players. So there's a real core of important players. And this is kind of like the template team idea, that everybody's team kind of looks the same. And that was one of the really interesting things we found. But I'm not going to go into too much detail here because I am running out of time. And another thing we looked at was just how similar two teams were. So if we have two teams, A and B, we could look at their level of similarity using what's known as the Jacquard similarity. So that looks at the intersection between two teams. So how many players co-appear divided by how many unique players there are in two teams. And if I do that calculation across the different tiers, we kind of see this thing that the better managers, so the purple line here, are more similar to one another than any other group. Okay, but we do see straight away that the better a team gets, the more similar it is with other teams, right? So there's this idea that focusing on a small subset of players is the way to go. Okay, there's plenty more I could talk about in this. I'm not going to, and I do apologize if you came to this stuff, but I'd be happy to take questions afterwards. I am going to conclude pretty quickly. On web scraping, it really isn't one size fits all. So we kind of talked about a few things there about IP addresses and random sleep times. They're all kind of higher level, but the kind of things I showed you today are a really good starting point in terms of extracting things from web pages. When I wrap up these thoughts and I try to think of a good description as to what this really means. And I don't know if anyone has seen the movie Gran Torino. It's a Clint Eastwood movie from maybe 10 years ago. A fantastic movie. If you haven't seen it, check it out. But the idea is that Clint Eastwood's this old army vet in the States, and this Asian family moves next door. And initially, he's kind of racist. He's an old army vet, but he kind of bonds with the family as time goes on in the movie. And one of the scenes really caught my imagination is that the young Asian kid there is visiting his garage, and he's looking at all the tunes, and he's amazed at how he collected all this stuff over time. And he's worried about how will he ever do that. But Clint Eastwood gives him a really nice quote. So he gives him 3 items. He gives him some WD-40, some vice grips, and some duct tape. And he tells him that any man worth his salt can do half of the household chores with just those 3 things. And I've always liked that quote because it works with a lot of different things. And web scraping is no different in that if just using the things I've showed you today, you can do an awful lot. Sure, there are more advanced things, but it's a really good starting point and you can go very far with it. Okay, I'm going to finish there. Thank you all very much for listening, and you can get me on Twitter there.
Good stuff. I think we're if you've any questions, folks, you can add them to the you could ask us the questions on the YouTube chat, and we'll pass them on to Joey. Joey, just actually, I'll start off with a few myself, actually. So I'm very interested in network science. This actually came to you separately from being a data scientist, but I think it's actually the type of thing that a lot of data scientists should actually look at more. Would you have any advice about how to get started? For example, that data set, like just to sort of learn the basics of it, because I think it's very an interesting subject for new people or people new to the area.
Yeah, I agree. Network science only really got big in the past 20 years, and it's really exploded because there are so many data sets describing interactions between people. And it's becoming increasingly popular in programming languages. So like if you Google network analysis in R, you'll get thousands of different tutorials and things like that with simple data sets, which are probably a better place to start. But there generally there's a network everywhere. It's just a matter of finding where it is, and people can really take advantage of that network to try to figure out different things in a number of different business problems, I think. So it's a really good thing to get into if you're a data scientist at a company.
Absolutely. I think that there's been a lot of very interesting projects with Star Wars data sets and Game of Thrones data sets. And it definitely is sort of like the R packages involved in those would definitely be worth a follow-up, particularly the ones that you mentioned there between the correlation and the networks. Another question, actually, there's network science, and have you ever looked at other things like graph databases, which is an extension of that, like things like Neo4j, or is that?
No, not myself.
A bit of a jump.
I have read about them. They are generally used for bigger problems than I'm used to. And I'm sure they are just the next level. It's a matter of knowing how to interact with them. And they are very much a toolbox in terms of fast computing and big scale computing. Sure, I think using Spark and Hadoop and things like that on standard network tunes would also work, but perhaps it does offer speed.
Okay, yeah. No, they're very interested in getting a talk on it sometime for YR here. There's just actually sort of like this presentation was an R, but just a quick primer. Like, there's obviously similar tools for this sort of stuff in Python. Do you know any off the top of your head?
Yeah, there's a fantastic module in Python, NetworkX.
Yeah.
That's fantastic for network analysis. I think there's also an iGraph one. So the iGraph's the main one in R, but I'm pretty sure iGraph has a Python relationship as well. So they're both there. But NetworkX is the standard, and it's fantastic. So do check it out if you're a Python programmer.
Okay, so like a lot of the stuff, like if you're a more Python focused person than an R person, that this you could actually do a lot of this sort of stuff as well.
Oh, for sure.
Okay,
yeah.
Good stuff. Tell me, actually, you mentioned Julia at the start. Have you looked at Julia? I know that the University of Limerick is solid supporters of Julia all along.
Yeah, there are network packages in Julia, and like most things, they're very, very fast. If you want to do something heavy on a network, I'd highly recommend it. There's been multiple different blog posts and things like that comparing the speed of their algorithms to those in Python and R, and there's really no comparison. So if you're looking for high performance computing, I'd probably recommend digging into it.
Good stuff, yeah. So the questions are coming in now. We have Mihi Retu. I apologize if I didn't pronounce that correct. The network science seems good for finding word networks in a text. Any advice about how to make appealing visualizations?
Yeah, this is one of network's big problems, I think. So the standard network libraries like iGraph and R and NetworkX don't have fantastic visualization tunes. There's some very good third-party software that do. One of them is Gephi, so Gephi. That's fantastic for making nice visualizations. I would very much recommend it. And I also think that the Tidyverse team are getting into network visualization. So they've had a recent GG graph functionality, which is getting better all the time. So you can check that out as well.
Good stuff. TP Flow Specialist asks, any ideas on how to make web scraping reproducible?
Reproducible.
Okay.
You mean in terms of different websites?
I'll tell you what. I'll let TP Flow Specialist sort of clarify that.
Some people have asked me this kind of question. If like for each different website, you have to cut up a specific scraper. The answer is generally yes, unfortunately. It's not one size fits all. Like I concluded with, every website is unique and has different tags and properties. So to scrape it correctly, you do have to get down and dirty with the background code.
Okay, good stuff. Just actually for myself, actually, web scraping. Have you any sort of a try to apply to anything like natural science or conservation or climate change or anything like that? Have you seen any of those applications in your travels, or is it little bit out there?
I haven't. I'd be amazed if there wasn't. I haven't seen them myself, but I don't see why there wouldn't be.
Okay, yeah. Yeah, it's sort of even to collect up some geographical data. So TP Flow Specialist just adds to his question about reproducibility. So like freezing the HTML on a repo or something.
Oh yeah, I actually seen a post about this recently. Someone was saying that it's a very good idea to use the what they call the Wayback Machine. So that's correct, isn't it? If you reference the URL through that. That's the best option.
Okay.
I never thought of that. That was a really good thought to me as well. That websites change all the time, so the code would break. You're right. But if you use a Wayback Machine, that fixes that problem.
That's an interesting idea. Now that's a good one. Yeah.
Good
so just a sort of a few more here. Just actually sort of one I'm interested in myself. With regard to Reddit and conspiracy theories, have you seen any work regarding, let's say, looking at QAnon and sort of seeing their scope? I know they're quite popular in the US, or sorry, quite prevalent in the US, but I'm guessing that they're might become more prevalent elsewhere. I was just wondering, has any work being done on that, let's say in Britain and Ireland, or even in Europe? Or have you seen anything like that? Or could this work be used to investigate that?
Yeah, I haven't seen any about them coming to Europe. I have seen some research into right-wing parties in Europe. So there are a few countries with right-wing governments. And of course, if you know that, I'm using the tools I talked about today, it's pretty easy to scrape the Reddits. One of the problems is that they tend to use other platforms, Parler and things like that. But again, they're probably scrapable as well. I haven't tried it myself. But there is an awful lot of research going into polarization, so how society is becoming more and more split in time.
Yeah, so there's a lot of this toolkit can be used to advance that research quite a lot. Good stuff.
I think so.
Tell us about you're in the west of Ireland, just like myself, actually. So tell us about what the data science community is like now in your part of the country. So I know you've got the data science research cluster there.
Yeah, I don't think there's many people in Ireland who know more about data science in the West than you, Kevin. Kevin's been a real driving force in that. But in more recent years, it has definitely expanded. In particular, at the University of Limerick, we have a Centre for Research Training, which takes 10 PhD students every year, maybe a bit more, with a specific focus on industrial-driven data science problems. So there's a very, very active, energetic data science community emerging from that, I think, which is great. The more the merrier.
Good stuff. And that's also got a good reputation in network science, which I think is a very fascinating subject area, particularly in data science, actually.
Yeah, and they're always recruiting. So if you are interested in doing a PhD, check out CRT, CRT-UL. That should give you an idea. There's also groups in Dublin and Maynooth, so it's very active.
Okay, good stuff. Let's see. Do we have any more questions? Sorry, just looking at my list here.
Okay.
I think we've hit everything there on the head. So I think I tell you what, I think we'll leave it there, folks. And I'd like to thank Joseph for joining us, and all the people from around the world who have joining us today. Again, I would once again like to thank our sponsors, Jumping Rivers, for their ongoing support of the webinar series, and all of the people around the world as well who sort of joined together in the R community, particularly in very difficult circumstances with the COVID crisis and so on. But we do get a real kick. We do get a real sort of sense of joy from seeing everyone around the world join us. So that's very important to us, and that's actually one of my favorite moments of these webinars, seeing where people are coming from. So I think we will leave it there. Next week we have another webinar at the usual time, 7 o'clock at 7 o'clock UTC, Universal Coordinated Time, 7 o'clock for where we are in the west of Europe, 8 p.m. in Europe. The name escapes me of the next week's talk. I'm very sorry about that, but we'll go. And we have a few more. If you'd like to give a talk in the future, we'd be definitely interested in hosting you, and definitely definitely consider reaching out to us if you have an idea for a presentation for a talk. We'd love to accommodate you. I think we'll leave it there, Laiz. That's great. Thanks very much, Joseph. Thanks very much, Laiz, who's our producer. And I think we'll